Welcome, everyone. This is secure coding for external app integrations with Force.com. Hi, I'm Asta. This is Tim. First of all, since this is the third day of Dreamforce, I am pretty sure that all of you know this by now, but please do not make any buying decisions based on this talk. All right. I'm Asta Senko, and I am a product security engineer at Salesforce.com. And as a part of my job, what I do is I work with product teams who are building applications for our customers. So everything that our developers are building for our customers to use, I work with them to make sure that it's secure from a design standpoint, from an implementation standpoint. I conduct penetration tests on Salesforce applications, and I work with the teams and provide better security training, make sure they have everything they need, enable more self-service for product teams, and helping them understand security bugs and guiding them through remediation. Today, in external app integrations, we're going to talk about how do you build secure integrations with the Force.com platform. And yeah, I'll hand it over to Tim.
All right, good morning, everybody. My name is Tim Bach. I am also on the product security team at Salesforce. One of the major roles that I have is conducting penetration tests on partners hoping to list on the App Exchange. So if I have failed any of your application reviews, I do apologize for that a little bit. The other thing I do is develop security automation tools to try and help our partners prepare for the review and be more likely to pass on their first submission. So we are actually working on a lot of really cool proactive vulnerability detection stuff and reporting tools for you guys. We hope to release that to you early in 2015, but there will be a link at the end of the presentation if you're interested in helping us beta test some of that. It's going to be some really exciting stuff. And like Asta, I work with partners on phone calls and conference calls to try and help them through the process, help them learn how to code securely. So let's talk a little bit about some of the stuff that we see our partners doing on Salesforce and some of the things that have security implications to us. So the talk today is about app integrations, and it's one in a series of talks that the security team has been putting on this week, talking about all the different ways that you can do things as developers with Salesforce and how to do it securely. But app integration specifically is when you're going to take Salesforce data and touch a third-party system with it, an application that you've developed that's not purely on Force.com and Visualforce. So an example of this might be if you were an electronic signature provider and you wanted to have the ability to do signatures from your customers in your opportunity objects or your sales objects in Salesforce and touch a third system where you're doing all of that. So one of the big things you're going to need is a way to map Salesforce user identity and data to these external systems. That might be mapping the opportunity objects to the actual signatures or the files in the other system, sending the data out there about the sales opportunity so that you can automatically generate a contract for someone to sign electronically. All these things for a connected flow that you have a lot of data in Salesforce, you want to get out to this third-party system. But we need to find a way for you to do that and have access to that Salesforce data without breaking our security model or the implicit trust that our customers have in everything on the Salesforce platform. So there are several methods you can use to actually integrate your apps with Salesforce. The most common of these is the API method using OAuth credentials. Now, OAuth is an open authentication service that allows you to delegate the authority for someone to use your user account to an external system without actually giving them your user credentials, including your password. What's going to happen is a token will be generated that should be treated with the same sensitivity as a password because it does allow you to do things with that person's user account. But the OAuth scope can be limited so that you can delegate only certain permissions to that external service. You can then use Salesforce's public-facing APIs to share data back and forth, grab data out of Salesforce, push data into Salesforce. And as developers, you can also develop custom Apex endpoints that you can call in that same API REST interface. Another option that we've made available is the connected app, which actually runs within the Salesforce.com application canvas. So this is not so much something that has access to the Salesforce DOM. It doesn't necessarily allow you to make new pages within Salesforce like Visualforce or Force.com would, but it does let you essentially frame your application into Salesforce. So it has the ability to make it look very integrated within the Salesforce wrapper. You can click an app tab in Salesforce, hop into it, and have access to your external system. Now, for that system to actually do anything with the Salesforce user account, you will still have to authenticate with OAuth or SAML the first time that someone uses it and get that OAuth token and the OAuth scope for the connected app. And that OAuth scope that you set up as a developer and what you request from the user using your app is going to determine the amount of access that that app has. So just like with straight up OAuth, we would expect you as developers from a secure point of view to delegate the minimum viable set of permissions for your application. Don't request permissions that you don't need, only request the bare minimum. Now, one of the simpler methods is Apex callouts. Now, the Apex callouts are easy. You can have a user-triggered action, make a post request to some external server. However, this can only be used to send data out of Salesforce. You can't pull data in with a callout, and it's not going to get you the same level of access that anything with OAuth would. So it's not exactly the preferred flow. If you just need to send a trigger to an external system and say, hey, this action happened in Salesforce, I need you to update something, you can do that. But we would really recommend that you go with one of the OAuth flows as a connected app or as a full third-party application, purely due to the additional functionality it gives you and also due to the additional security it provides to your users. So let's talk a little bit about the difference between authentication and authorization, because this is actually one of the things we run into in security review a lot, misunderstanding the difference between the two. And it actually is a very important difference. So authentication is going to refer to you. Who are you? What are you allowed to do? What have you been doing on the application? So it's your login, your session, and your user context. It only revolves around identity. Authorization, on the other hand, is what are you allowed to do? So that includes your CRUD and FLS settings on your objects. It includes what objects you're allowed to see, your access control, all the sharing profiles within Salesforce, the license type you have within Salesforce, all of that. So that's all contained within authorization. Now, when you mistake the difference between authentication and authorization, that's when you run into the issue of saying, well, someone is logged into Salesforce, so I'm going to let them do whatever they want. You need to control them in different spheres of your application. You need to log someone in and get their user context in one frame, and then when you're actually performing an access or an update to an object, that's when you need to check authorization, check the CRUD and FLS settings, and make sure that what your third-party app wants to do, that user is actually allowed to do within Salesforce. Because as part of the development platform, we're giving you total freedom within Salesforce. We're letting you write your own code. We're letting you do whatever you want as a third-party application. So we're not going to let you list on the App Exchange until we're sure that you're preserving the Salesforce model of security and trust. Because we're not going to let a third-party application do things with a user account that we wouldn't let it do on the core platform. The one other thing I want to talk about when it comes to authentication, authorization, how to log in as a user, how to act as a user in a third-party application, is secure credential storage. Now, when you're storing a credential to a third-party system, we want you to use a protected custom setting. And that's something that's made available to you on the Force platform. And that's going to allow users to set the secret in a custom setting. So the user will be able to set that information. And then you as the developer will be able to access that secret, perform the required operations such as logging into an external API, and get the end result of that operation back, such as the API session, getting the API session back to you, without ever actually controlling the secret. So you're not going to have access to dump a user's token or credentials to the logs, but you will have access to do what you need to do to make your app integration work. So this should be used to store any API keys that you're using externally. We did have a talk on this from our team earlier in the week, specifically 40 minutes of just talking about secure credential storage. So if you missed that talk and you are interested more in this, I do encourage you to go find the slides for that. Look up on our Twitter account or on the Chatter feed and try and get some information about that. So I'm going to hand it back over to Hasta in just a second to talk about some of our vulnerabilities, and she'll finish up with how to do credentials externally.
Mm-hmm. So we talked about, well, how do you bring in your system? How do you integrate your external system with Salesforce? How do you do the authentication and authorization part of it? Now, well, you have this OAuth token, right? And now in your external system, you need to call into Salesforce once the user has said that it's OK for you to do that. So you have to make sure that you are handling SFDC credentials externally correctly. What that means is whenever you're doing this on whatever platform, make sure you're following industry best practices for secure storage on the platform that you're using. Just the way we have custom settings for managed packages within Salesforce, based on the platform you're on, there would be other mechanisms that you can use. It's always advised to never try to reinvent the wheel for standard things like these, and try to use the industry best practice standard for that. And obviously make sure that whenever you're integrating with Salesforce, don't try to have user enter their username and password into your external site and store that, because when they are giving you an OAuth token, that's when they're giving you delegated access. And when they're giving you their username and password, first of all, they shouldn't be doing that. And second of all, they're giving you they don't have the ability to revoke that. When it's an access token, they can go ahead and revoke that if your application gets compromised, or if they want to stop trusting your application. So and for that same reason, it's also important to follow the principle of least privilege when defining your OAuth scope. And obviously, when it comes to access tokens, as we said, they're same as your user credentials. So never log it internally or externally, because you don't know where your logs are going to end up, right? So now we talked about how the integration works from the Salesforce standpoint. Let's talk a little bit more about what can you do for the external application that you're integrating with. Because a lot of times on the App Exchange, what happens is when people follow all the guidelines that we have up for secure coding on the platform, it's all good, and people understand everything that's going on, and they've taken all the care they can for, okay, follow CRUD and FLS, and make sure there's no socket injection, and make sure I'm using Apex tags for output encoding everything. But what about your external application? That also becomes a part of the review now that it's handling the Salesforce data, it's touching the Salesforce data, right? So when we're going to conduct a review on your App Exchange application, we'll conduct an end-to-end review of the whole system. What that means is if a little part of your application is something that is iframed into Salesforce, or is something where you have your Salesforce functionality built in, that means that your whole external application now becomes a part of your review. And obviously, the internet is a dangerous place, and web application vulnerabilities are very pervasive, and that's why we need you to do a thorough review of your external app as well before you submit. So let's talk a little bit more about the common vulnerabilities that exist on external web applications and how to avoid them. So first of all, everyone has probably seen this at some point in their life. So Crosssite Scripting. What is Crosssite Scripting? Crosssite Scripting means that an attacker is able to execute malicious script in my user's DOM. What does that mean? It means that when an attacker uses a vulnerable web application to send their malicious code, usually in the form of a client-side script, which then executes in my user's DOM. And now my victim end user has unknowingly given this attacker execute on their own DOM, right? So what's happening is here, one thing to understand is my user did not probably do anything wrong. They're just legitimately browsing Salesforce.com, or they're legitimately browsing application that they trust. The problem here is on the end of the application that they're browsing, where it's treating the user supplied data incorrectly. Meaning now when we say user supplied, in this case, there is the victim user and there is the attacking user, right? So your attacker user is also a valid user in the system. So when the attacker supplied input is reflected back on the web page without encoding it, it gets executed on the victim user's page. And that happens because there's poor separation between data and code context when you're talking about writing an HTML page. What I mean by that is when you're looking at the context. So here, for example, you have this HTML page, right? So there's your HTML blocks, there's your script block, there is an image source. So now, if you look at it, this is both data and code, meaning there could be part of this page that could be coming from the user that you want to display based on what the user wants to display here, right? So for example, here, if you only wanted the user to be able to specify the name in the script. So in the script block, if you only wanted your user to be able to specify the name, what's happening is your user is able to break out of that name context and then like, oh, okay, I'm already in a script block, then that means that I should be able to do something else while I'm in a script block, because now I am in the current DOM and I'm executing in the current DOM. So now when we talk about HTML pages, that's the problem, where there's a poor separation between code and data, and that's why, as developers, we need to make sure that we realize what context we are in, and then we treat the user data correctly based on the context we're in. Let's talk a little bit more about the different types of cross-site scripting vulnerabilities that we see. OK, so first of all, reflected XSS is the simplest one. I give the server an input. It comes back to me with the input in the response and does not encode it. And if the input somehow is able to break context and execute on my page, it'll do that. So what that requires is, for my victim user, I guess it requires my victim user to go and click on a link which sends that malicious input to the server in the first place, right? OK, well, if my users are smart, then that might not happen. Well, which is not true, because there's so many cat pictures on the internet, and we all click on them all day. So let's assume our users are very smart, doesn't click on random links, then they should never have to be attacked by a cross-site scripting vulnerability, right? No. Stored XSS. What does stored XSS mean? That means is my user my malicious user went in and stored their malicious input as the normal flow of the application. So for example, if I'm on, say, a forum, like if I'm on, say, Stack Exchange, right? And then people are submitting comments there all day. And if there was a cross-site scripting vulnerability there, then if I go to search, OK, how do I encode input on force.com, the Stack Exchange page that opens has a cross-site scripting vulnerability, and someone has posted a malicious script that executes on page load, then what would happen is, as a part of trying to go and find an answer on Stack Exchange, their malicious input is going to execute in my DOM. What that means is now they can basically do whatever they want, right? They can try to send my document.cookie to a third party. They can try to exfiltrate anything that my DOM has access to, which is pretty much, from a browser standpoint, that is pretty much the whole context of everything you're doing on the application, right? So the thing here is, having smart users doesn't prevent XSS. So what you need to do is, as the web server, you need to make sure that there aren't XSS vulnerabilities on your page. And then DOM XSS is something where when you first load the page, the payload doesn't get executed, but the user performs some client-side action on the page, because of which the DOM gets modified and the payload gets executed. So for example, if there was an XSS on, like, an on-click on the page somewhere. So when you first load the page, nothing happens. But when you on-click, then the DOM is being modified, and because of which the payload gets executed. So the last one's a little bit harder to detect from the standpoint of just looking at request response, if you talk about from an automated testing standpoint, because your payload is not malicious when the page is first loaded, right? Your payload, you can't detect that, OK, you're trying to break out a context here. So DOM XSS is a little bit harder to detect with automated scanners. All right, so we talked about context. We talked about the different types of injection that can happen. So HTML context, meaning when I'm in an HTML block, what will I do to execute my script, right? So like now I'm in the body of the page, all I need to do is I would need to start a new script block, and I can do whatever I want, and then I'll close the script block. The page is going to render correctly. Nothing bad's going to happen. My script's going to get executed. The user's not going to even realize. HTML attribute context. Now, when I'm in an attribute context, I don't even need to start a new block, right? Because you can execute script on attributes. So what I'll do is I'll just close the current attribute that I'm in, and then I will have an attribute which is like on load or on click, on error, which would execute my malicious script when any of those conditions are met. So that's HTML attribute context. Now, JavaScript context means, well, I'm already inside the JavaScript block, so I don't need to worry about starting a new script block. I don't need to worry about closing out of starting a new handler that would execute my script, right? But what I would have to do is I would have to make sure that I close the context of the current JavaScript string that I'm in, right? So all I need to do is I'll close the single tick, and then I'm out of the context of var name equals, and now I can do whatever my script wants to do, right? So based on this, it sounds like we have to do different things for XSS based on where my input's being reflected, right? So, so let's talk about mitigation, this seems really complicated, and this seems like something that should be a very, very hard problem to solve because I have to do a different thing based on where I am. So for mitigation of XSS, the first thing that you would do is you will constrain your inputs to an expected format. And the most important thing there is always having a whitelist of input, a whitelist of good inputs as opposed to a blacklist of, oh, I don't want you to enter script logs. Guess what? If you're not going to let them enter script logs, they're going to find another way to execute script in your DOM. Our browsers are really forgiving, and a lot of times you can rely on some old version of some browser to execute a certain form of weird HTML attributes. So the thing to understand there is if you only expect alphanumeric characters in your input, make sure that you're using that as a whitelist of allowed input, right? But there can be cases where you're actually OK with a user entering special characters, right? What are you going to do in that case? You can never say something like, OK, if your name contains an apostrophe, too bad, sucks to be you, and you're never going to be able to type your name correctly in my application. Well, that's not OK. So in that case, what you would do is you would do output encoding, because output encoding is the most important defense against XSS. What that means is you're rewriting user-supplied data so that it cannot break out of the structural context that it's in, meaning you're telling the browser to treat that special character as text and not as code. So you're trying to print the special character on the page and not execute it. So again, the thing that comes to output encoding is making sure that you understand what context you're in and making sure that you're encoding correctly for that context. So now when you're writing on the platform provides you a lot of built-in defenses when you're writing code on the platform. So you will use standard Visualforce components to render HTML. You'll make sure you never set escape equals false. You'll make sure that when you're writing custom JavaScript or when you're writing event handlers, you're going and explicitly encoding user input. And then make sure that you're calling the correct encoding function. Now, because now when you're writing using the Visualforce tags, you know that, OK, when I'm writing a Visualforce tag, then I know that the platform's already giving me platform protections. Now, when I'm writing custom JavaScript, I know that I'm going to be in a JavaScript context, so making sure that I'm using JS encode in that case. Or making sure if there's a case where I'm not using standard Visualforce tags, but I'm writing HTML, and or if I'm using a standard Visualforce tag with escape equals false, making sure that I'm HTML encoding the user input part of the whole thing, right? So make sure to encode explicitly in Apex when you are disabling default escaping. First of all, please don't disable default escaping. But if there is no other option and you really need to, make sure that you are explicitly encoding yourself. Make sure that you are calling the correct encoding function based on the context you're in. And make sure for custom JavaScript, for merge fields and event handlers, make sure you're JS encoding correctly. And other than that, the platform's going to take care of you, right? So for example, in this case, in the first one, what's happening is I am getting the current page parameter, and I am displaying the user input back as an output text, right? But is that going to be vulnerable to XSS? Yes, it is, because we're doing escape equals false, right? So we're telling the platform that I got this, and you don't need to encode anything. But you're just taking the parameter from the page, and you're displaying it back directly, right? Now, in the second case, you know that you're initializing a JavaScript variable from the current page parameter, but you're doing JS encode because you're in the JavaScript context. Now, in the third case, what you're doing is you're taking the merge field message, and then you're calling display pop-up on the message, right? So in this case, what's happening is you're doing a custom event handler. And we said that in the case of event handler, the platform's not going to know to JS encode it. So you would have to explicitly go and JS encode the message before you merge it into the callout for display pop-up. So these are things on the platform. Now, when you're writing code externally, what do you do? Well, first of all, make sure that you are using all the platform protections that come from the platform that you're using, because obviously XSS has existed for way too many years. that it shouldn't have been, and everyone has built-in protections from the platform that you're using. So make sure that you're taking advantage of that. Make sure you don't have coding patterns like document.write or evals. They should just not be used. It's 2014. And make sure that you're not doing inner HTML assignments directly, because when you're doing inner HTML assignments, then if your user input is going to be a part of that HTML element assignment, then your browser is going to think, okay, well, you want me to go and construct an HTML element with this user supplied input. That's not going to work, because your browser is going to think it is supposed to treat it as code if there's code in there. So make sure that you're using inner text whenever you can. Make sure to encode user input as close to the sink as possible. What that means is your data might be coming back in multiple contexts, right? So making sure that you're encoding it as close to the sink as possible so that you can encode it in the correct context. And then obviously use the security features provided by your platform or the templating engine instead of building your own. The problem with building your own is if first of all, there's a problem with being exhaustive in terms of, okay, I got everything that I need to encode. And second of all, what if something changes tomorrow? Are you going to go and find all of those encoding functions in your whole code base and change them? Well, probably not. You're going to miss some, and then that part of your application is going to be vulnerable to XSS. Now, and then during security review, we use a mixture of white box and static analysis and black box techniques to find all of these anti-patterns, to find instances like this. So this is usually like the first pass of the kind of issues that we're looking for. All right, I'll hand it over to Tim, and he'll walk us through some more vulnerabilities that we see on external as well as internal applications.
Yeah, I'm going to walk through 3 more vulnerabilities, and you'll notice that each of the ones I walk through gets about 20% of the time that Hasta gave to XSS, and there's a reason for that. Just doing some back-of-the-napkin math, if your application that you submit to security review includes an external component, there's roughly a 50–60% chance that we'll find XSS in it, and that's being conservative with my guessing. So it's really big. It's the #1 vulnerability on the web today. It's also easily the #1 vulnerability that we find. So we find that the application space in enterprise mirrors the consumer one. But please, please, please take what she said to heart, because even if you just have that one little reflected XSS and that's all you have, it's probably another 6 weeks of your time before you get to your customers on the App Exchange. So a little bit of due diligence goes a long way. Next up, SOCL and SQL injection. SOCL being the Salesforce.com version of SQL. So SOCL or SQL injection is caused by naively concatenating user input with the queries to your database. You'll notice a common theme here. Trusting your users is a fast way to get compromised. Using SOCL or SQL injection, a malicious user can exploit your benign database query to perform arbitrary database operations and retrieve or modify data they should not have access to. Basically, when you trust my name is Tim, and I say that my name is instead the ending clause of your query, and I also would like to dump your database, please, that's going to really, really set you back. I can do almost anything, especially when you use MySQL. There are some wonderful tools out in the wild. One of them is SQL Map, and when we find SQL injection, your report coming back from the App Exchange security team is going to list all of your database user passwords and probably your customers' passwords, and it'll just really be a bad day for you. So whenever possible, please, please, please do not use dynamic database queries. Use bind variables if your platform supports them. If your database language supports them, use prepared statements. And at the bare minimum, if you're using PHP, use their SQL libraries to escape every piece of user input that you put into a database query. And again, whenever possible, just like with XSS, use a pre-built API if you can. There's no reason for you to reinvent the wheel when it comes to security. Next up, cross-site request forgery. This is something that is just pervasive throughout the internet. And it's hard to wrap your head around for a little while until you really understand it. So I'm going to try and use a bank example. But to start with, let's lay the groundwork. Everyone knows of cookies. Your browser receives them after a website sets them. In general, they are the most common way to store session ID tokens, and your session ID token lets you do everything you want on an application. What this means, every time your browser makes a request to a domain, it's sending all the cookies for that domain because it's trying to be helpful, it's trying to follow the rules, it's trying to make sure you have that session ID with you every time you make a request to a website. So an attacker can make legitimate requests or make illegitimate requests that appear like a legitimate request with an authenticated session. So the bank example I was talking about. Let's say, so I bank with Bank of America. I logged into Bank of America's web interface, and they don't have any CSRF protection. So I'm logged in, my session is still active, and I close out of Bank of America, and I immediately go over to Reddit. I look at some cat pictures, and one of them is on an attacker's website. Now that attacker, instead of including a cat picture in the image source tag, has included the URL to transfer $1,000 out of the account that's logged in Bank of America to his account. And my browser thinks I'm loading an image from some other server. So it makes a request to bankofamerica.com/transfer.aspx, gives it all the variables in the URL. My browser sends all the cookies with it. Bank of America receives it, and bam, I've transferred $1,000 to an attacker. So how do we stop this? It's actually really simple, and almost every platform has a built-in function to do it. It's going to be CSRF tokens, and it's something that is included in the post body of your request. It's a unique token per user, per session, and it verifies that the request actually came from a user action. It's not going to be included in a cookie because you're not going to set, at least you're not going to check the CSRF token from the cookie. You're going to check it from the session store on your server. The Salesforce platform does automatically add CSRF protection to all of our post requests. What this means for you, perform any user state change requests and user modification of data via a post request. Make them click a form button. Don't do something when a page loads via a GET request. Thanks. Yeah, that's good. To test for CSRF, identify state changing operations and look at those. Make sure you have that protection. Use an open source tool like Burp or Zap. Or sorry, Burp's not open source. Use an open source tool like Zap or pay for a tool like Burp. Identify the CSRF token and then remove it. And then send your request again. If it works, even once you remove that token, unfortunately, you are vulnerable to CSRF. You should go back and look at where you're verifying your CSRF token from. If it doesn't work, throw an error, log the user out, do something. Congratulations, you have prevented CSRF from occurring. Now, the other thing I want to make you aware of is that reusing CSRF tokens across users and across sessions defeats the entire purpose of them. So please, at least 128 bytes of entropy, or 128 bits of entropy, sorry. 128 bits of entropy in each token per user per session, and that will be the industry standard. So the last one I would like to talk about is my personal favorite vulnerability on the internet today. It's remote code execution, and it comes from developers just being so trusting of our users. Let's say I want to set a profile picture on your forum or your document signing service. You let me as a user of your document signing service set a picture so that when I sign it, you can look in the history in Salesforce that's connected to your third-party application. And your third-party application has this picture of me, and you want to show this awesome UI that shows my headshot and says Tim Bach signed for this sales order. Awesome. However, if you are not verifying what kind of files I'm uploading and you're serving those files from your server, then I will, instead of my picture, upload a PHP file that is actually an online shell file. I will then go to the URL that you are trying to serve my picture from, and I will have full web shell running in my browser, and I will just start dumping your password files and reading your source code files. And when I can read your source code files, I can find all the other vulnerabilities in your application. And then if I was a real attacker, maybe when I'm done, I put a little, one extra line of code in your source code file, so every time a new user tries to sign a document, it actually sends all the information to me, and then I'm contacting your users with phishing emails and saying it's from you. It's just bad for everyone. So major ways to mitigate this. Check what kind of file is being uploaded, and do not serve the file from your main domain. Serve it from a content distribution network, serve it from a subdomain, serve it from a third-party domain altogether, just salesforcecontent.com or something. Do one of these things, and then even if I do upload that file, I won't be able to run it, and I won't be able to access your code. And even better, don't run your web application as root. So I believe that is the major bits we have for you today. If you have any questions, please feel free to ask them now. Hasta, you want to take that?
Yeah, so I think you're trying to ask that when you're trying to integrate an external application into Salesforce and then you're getting the external user to log in and then you need that for the rest of your Salesforce session, how do you store that information? Is that? Okay, so one thing, it depends. So if you, obviously, if you have OAuth implemented on your external application, we would recommend that you get an OAuth token for your external app, and then you use protected custom settings in the managed package to store that OAuth token for your external app inside of Salesforce. That would be the best secure storage you have available on the platform. So what that would mean, so an OAuth token would basically mean that, okay, I have given this application running on Salesforce.com delegated access, and now on the external server, when that external server is going to see the OAuth token in the authorization header, it's going to go, okay, this token has access to these resources, so okay, I'm allowed to return these resources. So it's going to be the same, but more tightly controlled. You're just going to, so if you are doing a OAuth 2, then if you have a refresh token, then you'll get an access token, and then access token is going to act as a session ID. Yeah. Mm-hmm. Not really.
Passing the session ID from the user context of the Salesforce application out, no, we don't regard that as a secure way of doing things. We don't explicitly prohibit it, but it's definitely not secure. And the reason for that is that when you pass a session ID out, you as the application now have full access to the user's information. You're essentially them. And that's a poor experience for our users because they cannot revoke that access later. So what we prefer to see is the OAuth flow. And if you want to be inside the Salesforce DOM, the connected app setup with the OAuth flow would be the way to go for that.
And is there a way to stop this? I know there is a setting on the bottom level where you can enable that setting that restrict the session from the API.
Right. That's one of the big things that the Salesforce platform offers in terms of security for our users is restricting based on IP range. So a lot of our clients, and I mean Salesforce internally definitely, we use IP range restrictions, which means that even when I log in from work, if I try and go log in off of our VPN, I'm not allowed to because that IP is not even in our range.
We'll upload the slide on the chatter of the session on the Dreamforce app, so you should be able to download it from there.
Yeah, just log into the Dreamforce Success community, and we'll... Yeah, so go to the actual session page, and we'll upload the slides to the chatter feed of the session.
We'll also tweet the link out from Secure Cloud Dev, the Salesforce security Twitter handle. So.
So the review process is not predicated on the type of integration. It's if you are listing on the App Exchange publicly, period, you will go through a security review. And the scope of the security review is defined by whether or not any part of your application touches a third-party system. If it does, we will be reviewing that entire third-party system.
Obviously, by having application within my automation company,
then we will not, right. The security review is before you are allowed to publicly list an app on the App Exchange. Yeah, SOCL does support parameterized queries, and if you go into the Developer Force security pages and the Developer Force documentation, there's a lot of good stuff there about specifically how to do it. Okay, thanks guys. I think we have to clear this room for the next session, but we will be right outside if you have anything else.